Hello, here we're going to take a look at some patterns of numbers. Now, a nice mathematical word to talk about patterns is something called a sequence. It's a pattern of numbers in math. At least that's a very basic definition of what a sequence is. So when I talk about a sequence, I'm saying, what if I have 4, 6, 8, 10, 12, and that goes on? What's my pattern? Adding 2. I could have a sequence of 1, 3, 9, 27, and so on. What's my pattern there? Well, I'm multiplying each term by 3. In fact, that type of sequence is what we're going to look at today. When I multiply each number by the same thing, I call it a geometric sequence. A sequence where the first term is non-zero, because I have to give something to start with, and each term after the first is found by multiplying the previous term by a constant r. So that's just kind of a label we give the constant. The constant r that multiplies each term in a geometric sequence is called the common ratio. Just a label that we give to our common multiplying factor. So notice here I'm multiplying by 3, multiplying by 3, multiplying by 3, so my common ratio, my r, is equal to 3. Now this one up here, I'm not multiplying, but I am adding 2 to each one. When I add the same thing to each term in a sequence, we call that an arithmetic sequence. We're going to be focusing on geometric sequences today, but arithmetic sequence is kind of the other major type of sequence that is talked about often, so I want to bring that up. Because as we practice a little bit, starting off here, determine if the sequence is arithmetic, geometric, or neither. I want to have that arithmetic in the back of our mind. Okay, the best way to check what type of sequence a sequence is to start at one of the numbers and then go backward and see how do they compare with each other. Now off the top here, I'm looking, I'm subtracting 32, I'm subtracting 64, I'm subtracting 128. So I'm not adding or subtracting the same number to get to each one. So it's not arithmetic, maybe geometric. So to check if it's geometric, I take a term and divide by the term behind it. 32 divided by 64, reduce that fraction 1/2. Okay, I take the term 64, divide by the term before it, 1/2. 128 divided by 256 reduces to 1/2. So I notice that I'm multiplying each number by the same 1/2 to get the next one, which means this is geometric with a common ratio of 1/2. To get each number, I just multiply by 1/2. B. Is it arithmetic, geometric, or neither? Well, let's see, going backwards, let's check arithmetic. Here I'm subtracting 6, subtracting 3, subtracting 5. Okay, that's different every time. So not arithmetic. Geometric, 18 divided by 12. Well, that would be reduced 9 over 6, 3 over 2. 12 divided by 9, reduced that would be 4 over 3. And already I'm different, so I'll just stop there. This is neither geometric nor arithmetic. Now let's zoom in on geometric a little bit more. You can find some interesting things about it. Find the 15th term of the geometric sequence -6, 12, -24, 48. In fact, we're going to see there's a way to do this where we don't have to go 15 terms, write them all out. We can actually kind of come up with a formula that directly tells us what the 15th term is. And maybe we can put together a pattern and recognize the pattern and discover that formula for ourselves here. So first thing I want to do is I want to see, well, what is the common ratio in this? So once again, let's take one term, divide by the term before it. Okay, 48 divided by 24, negative 2. Negative 24 divided by 12, negative 2. 12 divided by negative 6, negative 2. It looks like I'm multiplying each number by negative 2. So I have the common ratio of r is equal to negative 2. Multiply each of my terms by negative 2 to get the next one. It's okay to have a negative common ratio. Perfectly fine. Let's lay this out and see if we can't figure out the rule to find the 15th term, or to find any term in the sequence. Some notation here. We like to use this notation when we're dealing with sequences. I'm going to say a sub 1. That means I'm talking about a term in the sequence, so that's my a. And which term? The first term. That's my 1. A sub 1 is equal to negative 6. That's the first term. I'm also going to write it like this. Negative 6 is equal to negative 6 times negative 2 to the 0th power. Bear with me while I'm writing it like that, but negative 2 to the 0th power is just 1, so negative 6 times 1 is negative 6. Second term, a sub 2 is equal to 12, which that's equal to negative 6 times negative 2, which is equal to, bear with me here, negative 6 times negative 2 to the first power. Let's try the third term. A sub 3 is equal to negative 24, which is equal to negative 6 times negative 2 times negative 2, which is equal to negative 6 times negative 2 to the second power. See, here I've got two negative 2's, so that's same as negative 2 squared. What about the fourth term? A sub 4 is equal to 48, which is equal to negative 6 times negative 2 times negative 2 times negative 2, which is negative 6 times negative 2 to the 1, 2, 3, third power. We're starting to see somewhat of a pattern, so that on the fifth term, we can maybe shorten this. 48 times negative 2 would be negative 96, which is equal to negative 6 times negative 2 times negative 2 times negative 2 times negative 2. As you might expect, there are 4 of them, so it's negative 6 times negative 2 to the 4th power. Can we generalize the pattern we see going on here? Let's see. Well, I notice every time that I'm finding the next sequence, I'm multiplying by negative 6. So I feel like that negative 6 is going to be in my formula somewhere. I also see on the first term, I'm multiplying by negative 2 to the 0th power. So I'm also going to be multiplying by negative 2 somewhere in my formula. But to what power? Well, in the second term, I take negative 2 to the first power. On the third term, I take negative 2 to the second power. On the fourth, I take negative 2 to the third. And on the fifth, negative 2 to the 4th power. Notice, every time I'm finding a term, I'm multiplying negative 6 by negative 2 to a power 1 less than the term I'm on. So if I'm trying to find the 8th term, if I try to find a sub 8, it's going to be negative 6 times negative 2 to the 7th, according to my pattern I've got going here. Let me emphasize, it's important to have that in parentheses because it's negative 2 being multiplied 7 times, not just 2 and then tacking on a negative. So keep that parentheses there to remind you it's negative 2 times negative 2 times negative 2, like that. Okay, taking a look now, I'm going to write a rule where I'm going to say what is a sub n. When I say a sub n, I'm saying I'm trying to find the nth term in my sequence. It's a way to talk generally about some random term in my sequence. A sub n, so what is that term? Well, I know that I'm going to go -6 times -2 to the what power? What power is it going to be? Well, if I'm on the nth term, it's going to be one less than that, so it's the n-1 term. That rule right there allows us to find any term in my sequence, in my specific sequence up here. So that means, what is the 15th term? Well, I'm going to go a sub 15 is equal to, so I'm trying to find the 15th term, -6 times -2 to the 15 minus 1, which is 14th power. So that's -6 times, well, since I'm taking -2 to an even power, I know it's going to be positive. And in fact, this is going to be a really big number. 2 to the 14th. Oh, well, it's not so bad. It's 16,384 times -6, -98,304. That would be the 15th term. And even though it took us a while to derive that formula, now that we have a general notion of it, it's going to be a lot quicker to find terms in other geometric sequences. In fact, let's take our formula right here and generalize it a little bit. -6, what is that in the sequence I have up here? It's my first term, so I'm going to relabel that a sub 1. What about, what is -2? In terms of my sequence, it is the common ratio, r, which we labeled r. So I'm going to relabel it r. And now this is the big thing to keep in mind. The formula, or the rule to find an nth term in your sequence, that is like any term in your geometric sequence, a sub n is equal to a sub 1, your first term, times r, your common ratio, to the n-1 power. And with that rule, any geometric sequence, that's a sequence being multiplied by a common ratio, you will be able to find any term in that sequence. I could find the 20th term, the 30th term, by just plugging in 30 or 20 or 111 in for n, and you'll find that 111th term. Pretty neat.